Hello, pre-calculus student. This video is for chapter 6.3, inverse trig function. So we have our 6 trig functions, sine, cosine, tangent, cotangent, secant, and cosecant. Each one of them is a function. You can create inverse function from them. Just like before, what is an inverse function when we mention inverse function? So for example, I have a function that is y equal to x squared. What is the inverse? The inverse would be um, how a function that get rid of the square. So the inverse would be y equal to square root x. Remember, to solve an inverse function, um, because when you have a number, say for example 3, you go through the first function x squared, you have 9, and I want to do the inverse that would get back to 3. So that would be square root 9, square root x would get back to 3. So they cancel each other, kind of starting from the beginning. If we go back to the function of a value, and then if you go back, you get the original input. So this is the same idea. Let's look at an example. If I have a sine function, I start off with pi over 6. In a unit circle, I have a unit circle at the bottom. Here, if I have my input as pi over 6 over here, my sine would be 1/2, right? I read pi over 6 as the input, and I get 1/2 as sine output. So you can visually say that input is pi over 6, output is 1/2. We can draw a function diagram. Pi over 6 is the input. I go through sine using the unit circle, and I see that my output sine of x is 1/2. So what is the inverse function is? The inverse function is get 1/2. If someone give me 1/2, I will get this 1/2 and tell people your output is pi over 6. So it's like canceling the sign operations. Pi over 6 become 1/2 for sine, but sine inverse will change the 1/2 back into pi over 6. So when you do the sine inverse function evaluation, basically, if you're doing sine inverse, you look at all the y value in the unit circle as your input, and then you look at which one match your input, and the value, the angle is your output, right? So for example, another one, if I have my input is pi for cosine, so pi is here, cosine is -1. So over here I say um, cosine pi is equal to -1. Well, how do I write my inverse? I will say my inverse is cosine inverse of -1. So if I know -1, I can read off it's being pi, right? So I would look for inverse cosine. I look for all the x value match my input, so I don't go like the angle, and then I match -1, so I tell the cosine inverse will produce a output of pi, right? So that means for pi, I use cosine with the unit circle. With unit circle, I see -1. For cosine inverse, I see -1. I look up the uh, x component of the unit circle, but it's a reverse lookup, and I call it cosine inverse. My answer is pi. Likewise, want to do one more example is, so I should write it this way. Cosine inverse -1 is equal to pi. What about tangent pi over 4? If I look at the unit circle, tangent pi over 4, I will look at my angle pi over 4. Tangent is y over x, so I'm going to do it here. Tangent pi over 4, and look at the unit circle of both x and y, and I do root 2 over 2 over root 2 over 2, y over x. So I got 1. So what happened is when I do the inverse lookup, I would do inverse but 1. So which pairs of a value when they divide each other for y over x is equal to 1? Now that's a little harder. So usually it's better if we have a tangent number next to it. So that's what I suggest. So you know this is root 3 over 2, this is 1, and this is root 3. You pre-do some tangent number, and then you look at, oh, these pairs will give 1. So my answer is pi over 4 for the tangent inverse. So this is the example that what this is the example that what we mean. So I should write it as pi over 4. So just remember for the sine inverse, the input is a ratio, is a number, is the x or y. When I say ratio, is the x or y over x, any of the, we can say x over 1. And then so this is the function, but the inverse function will take the x and y over x. You cannot have number that's over those ratio, and your output range is the measure of an angle. When you evaluate it, you look at the unit circle, you do reverse lookup. You look at the x and y as your input, and then the angle is your output. Now, let's work on this a little bit more. Look at this. Earlier, when we say sine pi over 6 is 1/2, so sine inverse 1/2 is pi over 6. But you know, when I look at y, 1/2 is pi over 6, that's right. But when I look at more y, I see this 1/2 is also 1/2 of, why shouldn't I do pi over 6? It turns out that for a function to exist, it can only have one output, so we don't want this. We only want 1/2. So then you may say, Miss Chan, then which one do I choose? Why can't I choose that one? And what about negative 1/2? If I look at negative 1/2, I see one here, which is 11 pi over 6. I also see a negative 1/2 for sine. It's 7 pi over 6 for reverse lookups. Which one should I choose? So I choose this one because it's closer or something. It turns out that we don't choose. Oh, I want to erase something. Can't go up to it. Oh, something wrong with my writing pad. Okay, so this is, yeah. So so that is our problem when we have a input. We have two output. 1/2 I have this output, right? Root 2 over 2, I have root 2 over 2. I have 3 pi over 4 as well, pi over 4. So you can see that this is really because sine is not a one-to-one function. So um, to solve this problem, we restrict the domain of the sine function, and we restrict it in such a way that we want a domain to be negative pi over 2 and pi over 2. So if you look at the sine function, the sine curve, if you only plot from negative pi over 2 and pi over 2 is this way, it's a one-to-one function. So I would have no problems of finding a output value. In the unit circle, what would happen? Negative pi over 2 does not show up. So what happened is we would have to relabel this. If this is a unit circle for your inverse lookup, reverse lookup, so you should have a unit circle for reverse lookup. So so this is you don't do 2 pi, you just do 0. This you don't do negative pi, you say it's pi over 6, pi over 4. It is right, it is negative pi over 4 and negative pi over 3 because it's a negative angle by rotating down, and this is negative pi over 2. So when you reverse look up negative 1/2, you don't look at this two quadrant at all. You only look at sine, and sine would be this two quadrant 1 and quadrant 4 for sine inverse. Sine inverse. And then for tangent inverse, also sine tangent inverse, with the angles being relabeled as pi over 6 and negative pi over 2. Why can't we use 11 pi over 6? Because it's kind of not contiguous. Think about it. If you have an angle from negative pi over 2 and then negative, negative, and then 0, it is continuous. You can see that you can graph the function nicely. And then the inverse graph would just be a reflection over y equal to x, and it will be very nice. What about cosine? Cosine has if you look at cosine, we reverse look up, we would look at the x value. So these are positive, positive, positive. So it's really good. We will use this for our first quadrant. And then in the second quadrant, you'll see that you have cosine negative, and they are contiguous already. So for cosine, we use quadrant 1 and 2. You can see that the output is always positive. So even when you have a negative 1/2 as the input, the output is 2 pi over 3, 3 pi over 4, and 5 pi over 6, and pi. So cosine inverse, you use this quadrant 1 and quadrant 2 for reverse lookup. And for sine and tangent, you use quadrant 1 and quadrant 4 with reverse lookup with quadrant 4 relabel as negative angle. Okay, so so this is how the graph look like. You have negative pi over 2 to pi over 2. For the cotangent, the graph would have the output y has always the positive angle from 0 to pi. So let's do one example. So this is kind of like the major stuff. You might want to ask why do that, because why can't I use sine for negative? Use this quadrant 3. It's just that the angles are more contiguous, and people has decided to restrict the domain that way. So that's what it is. Okay. Example 1. What about for non special angle? You just go use the calculator. So like for example, okay, so this is writing a relation, so you can understand. If someone tell me in the calculator that sine 5 pi over 12 equal to 0.96593, so can you write it in inverse sine? Well, I would say the inverse sine of 0.96593 should equal to 5 pi over 12, right? And you can check it in the calculator. What about cosine pi upon 5 is, I think this is 0.5, 0.5. So I would say cosine inverse of 0.8776 would equal to 0.5. Okay, so this is the unit circle. So I have the reverse lookup instruction here to find the inverse trig function related to special angle. Reverse lookup. So what are the inputs? You have to recognize that if you guys run into value of 1 with 3 over 2, root 2 over 2, 1/2 for sine and cosine, they are special angle. They would get into these pi over 2, pi over 3 types of angle. And for tangent is would 3, negative would 3, 1, all those. So, but for sine tangent, look up quadrant 1 and quadrant 4. Quadrant 4 use negative angles. For cosine, look up from quadrant 1 and 2, and both positive angle. So now, let's practice evaluate each of the following. Maybe I'll go use the second video to talk about how to evaluate. So this video is about concept and about how to do reverse lookup. And you should have a separate, unit circle. You use this one that is just for trig inverse lookup.